Hi friends, good morning one all. Today we are going to discuss about the Aryl diazonium salts. This is the molecular formula of Aryl diazonium salt. Benzene diazonium halides. Here, this Aryl diazonium salt is prepared by diazotization. Here, aniline when we react with sodium sulfide in the presence of hydrochloric acid and 0 to 5 degree centigrade to get benzene diazonium chloride. So this reaction intermediate is useful for the synthesis of number of compounds. This benzene diazonium salt is very useful for the preparation or synthesis of n number of organic compounds. Now we will see one by one. Here benzene when we react with nitration mixture to give nitrobenzene. Again, this nitrobenzene when we react with stannous in the presence of hydrochloric acid we get aniline. This aniline again react with sodium nitrate and in the presence of hydrochloric acid to give benzene diazonium chloride. So this reaction intermediate is very useful for the synthesis of n number of organic compounds. Various number of organic compounds. Now I will see one by one. Here, this benzene diazonium salt when you react with copper chloride to gives chlorobenzene. The same benzene diazonium salt when you react with copper bromide to gives bromobenzene. Here, so same benzene diazonium chloride react with copper cyanide to gives cyanobenzenes. So these three reactions are called Sandmeyer reaction. These three reactions are called Sandmeyer reaction. Once again I am repeating here, the benzene diazonium chloride is a reaction intermediate. It is very useful for the synthesis of various organic compounds, and this aryl diazonium salt is prepared by this method. Here, benzene when you react with nitration mixture to give nitrobenzenes, and this nitrobenzene when you react with stannous in the presence of hydrochloric acid to get aniline. So this aniline again react with sodium nitrate in the presence of hydrochloric acid to give aryl benzene diazonium chloride, aryl diazonium salts. So this benzene diazonium chloride when we react with copper chloride to gives chlorobenzene, and same benzene diazonium chloride when we react with copper bromide to gives bromobenzene. Again, benzene diazonium chloride when we react with copper cyanide to gives cyanobenzenes. So the name of these three reactions are called Sandmeyer reaction. Here same benzene diazonium chloride when we react with HCl in the presence of copper powder to use chlorobenzene. Here the same benzene diazonium chloride when we react with hydrobromic acid in the presence of copper powder to give bromobenzene and nitrogen gas. Here the benzene diazonium chloride react with hydrogen cyanide gives in the presence of copper powder to give cyanobenzenes. So here also we get same product, but the reagent is different. Here the used reagent is different. Here only the copper chloride is used or copper bromide is used. Any copper halide is used here. Here the hydrochloric acid and copper powder is used here. So name of this reaction is called Gutterman reaction. Yes, say benzene diazonium chloride react with HbF4 the presence of heat to gives fluorobenzene. Here benzene diazonium chloride when we react. Now we will see another example, that is tertiary alkylamine. Here the tertiary alkylamine when we react with potassium permanganate to gives tertiary nitroalkane. Here NH2 groups, amine group is affected with KMNO4 to gives nitroalkane. Primary aromatic amines when we react with fluoroperistic acid to gives nitrobenzene. Here oxidation is taking place here. Here aniline when we react with peristic acid, that is trifluoroperistic acid, when we react with aniline to gives nitrobenzene. Here primary aromatic amine we react with sodium dichromate to gives parabenzoquinone. This is the primary aromatic amines when we react with sodium dichromate to gives parabenzoquinone. Earlier, say aniline when we react with CF3COOH, this is This reagent is called trifluoroperistic acid. So when we react this primary amine trifluoroperistic acid to give nitrobenzene. Again same primary amine when we react with sodium dichromate to give parabenzoquinone. Secondary amine when we react with the condensation reaction. Here the second two molecules of secondary amine react with peristic acid and potassium permanganate to give tetraalkyl hydrogen. Here see here this is secondary amine and secondary amines. So here two molecules of secondary amines react with KMnO4 and peristic acid by losing hydrogen molecule to give tetraalkyl hydrogen. NH2 is hydrogen, and here two hydrogens are substituted by alkyl group, and here two hydrogens are substituted by two other alkyl groups. That's what this is a tetraalkyl hydrogen. Here the tertiary amine when we react with the peristic acid to gives N oxides. Here the tertiary amine when we react with peristic acid to gives N oxide salt type compound we obtained here. Next reaction is condensation with carbonyl compounds. Here aniline when we react with aldehyde in the presence of heat by losing water molecules we get imine. Here this is RNH2 is a primary amine and RCHO is a aldehyde. When you react there, the condensation reaction between amine and aldehyde in the presence of heat by losing water molecule to gives amines. So RNH2 plus RCHO in the presence of heat by losing water molecule to gives imine RN11CHR. Here aromatic amines when you react with aromatic aldehyde in the presence of heat by losing water molecule to gives aromatic imines, that is called Schiff's base. Now we will see electrophilic substitution reactions. Here before going to see this reaction here, the reactivity order we will discuss. Here the aniline is more reactive than phenyl because here the aniline in the phenyl ring aniline amine group is there. This amine is a more electron rich moiety and it increases electron density at benzene ring. That's what these are the OP directing groups and more reactive than phenyl benzene. So now we will see nitration reaction. Here aniline when we react with HNO3 to gives salts. These salts again react with HNO3 to gives nitro salts. Again on hydrolysis of this nitro salt in the presence of base to gives nitroamines, meta-nitroamines. Okay. Here once again I am repeating. This is the nitration reaction. Here aniline when we react with HNO3 to gives nitro salt, salt. This salt again react with the HNO3, nitric acid to gives nitro salts. On hydrolysis of on reaction of base, this nitro salt gives meta-nitroamine aniline. So this is the nitration reaction. I will see another reaction. It is halogenation reaction. Here aniline when we react with bromine in the presence of water to give tribromoaniline. Here after monobromination reaction cannot be stopped because reactivity of aniline is more. Therefore tribromination is takes place. Okay, this is the halogenation reaction. Coming to the another reaction, that is sulfonation reaction. Here aniline when we react with sulfuric acid to gives anilinium hydrogen sulfate salt. Then again heat this anilinium hydrogen sulfate salt in the presence of 100 degrees centigrade to gives sulfamic acid. This sulfamic acid again heat to gives sulfonic acid. Here the starting material is aniline when you react with sulfuric acid to gives anilinium hydrogen sulfate salt. when we heat this sulfate salt in the presence of 100 degrees centigrade to give sulfamic acid. Yeah, this sulfamic acid when we heat to give sulfonilic acid. These are the sulfonation reaction of aniline. Coming to the another reaction. Now we will discuss about the separation of amines. These are the very important for your examination point of view. Here the Hinsberg, here two methods is there. The first one is Hoffman method and second one is Hinsberg methods. Here the Hoffman method is here the mixture of amines when we react with diethyl oxalate to give oxides of primary amines, oxamic esters of secondary amines, and amines, tertiary amines. So here the oxides of primary amine is solid and oxamic esters of secondary amine is liquid and tertiary amine is liquids. So here this mixture is obtained when we react this mixture of amines when we react with diethyl oxalates. Then again on filtration this mixture we get oxalate solids. Hydrolysis of this oxalate solids gives primary amines. And the second part is the mixture of two compounds that are oxalic acetate and tertiary amines. So when we fractional distillation this the tertiary amine is separate out. Then the oxamic ester is there. On hydrolysis of this oxamic ester in the presence of potassium hydroxide to give secondary amines. These are the separation method of tertiary, primary, second, tertiary amines. These are the very important. Again repeating you, these are the when we react the mixture of amines with diethyl oxalate to give oxamide of primary amines. This is solid, and oxamic ester of secondary amines. This is liquid, and tertiary amines. This is also liquids. So when we react this mixture or when filter this mixture to give the primary amine is filter out with water. Then the second part is the oxamic ester liquid and tertiary amine liquids. So when we react on fractional distillation here, tertiary amine is separate out. Then the oxamic ester is there. Now oxamic ester when we react with potassium hydroxide in the presence of water to give secondary amines. This is the separation method of primary, secondary, tertiary amines. Now the second one is the Hinsberg method. This is very important for your examination point of view. Hinsberg method. Here the tosyl chloride or benzene sulfonyl chlorides. These are the Hinsberg reagents. Here the benzene sulfonyl chloride or tosyl chlorides. So when we react the mixture of amines, these are primary amines, secondary amine, tertiary amine, and quaternary amines, quaternary salts. When we react this mixture with ether, here the insoluble quaternary salt is separate out. Then the soluble primary, secondary, tertiary amine is one part. Then when we react this mixture, this soluble mixture with benzene sulfonyl chloride or tosyl chloride, here we get sulfonamide, second sulfonamide, and tertiary amines. So this mixture when we react with dilute HCl to give tertiary salt with potassium hydroxide, we get tertiary salt, and the primary and secondary sulfonamide obtained on reaction with aqueous sodium hydroxide. Here the secondary ester solution, secondary sulfonamide is separate out, and the primary sulfonamide is separate out. When we react the primary sulfonamides with the aqueous solution and on the presence of acetic medium, primary amine is separate out. The secondary sulfonamide when we react with potassium hydroxide in the presence of on distillation of this primary secondary sulfonamide with the potassium hydroxide to give secondary amines. These are the substitution method of primary, secondary, tertiary amines with Hinsberg method. This is the very important. So once again I am repeating you. So when we react this four mixture with ethers, insoluble quaternary salt is separate out. Then the three mixture is soluble in ethers. Then these three mixture when we react with benzene sulfonyl chloride or tosyl chlorides to give primary sulfonamide, secondary sulfonamide, and tertiary salts. When we react this mixture with dilute HCl, here we get uh, we get tertiary amines on potassium reaction with potassium hydroxide. And again the second part is consist primary and secondary sulfonamide. These primary secondary sulfonamide, when you react with aqueous sodium hydroxide, here we get two types of two products. This is the first product is react with aqueous solution and the presence of acidic medium to give primary amines. The second point, when you react with ether solution to give ether solution and potassium hydroxide and distillation to give secondary amines. These are the separation method of primary, secondary, tertiary amines. These are the very, very important for your examination point of view. Please. Okay. Now we'll see another test, another reactions.